So let's see, here we go. Okay, so just remember, like, okay, what does Docker really give us? And the idea is we can have these, when we build an application, whether it's a web application, could be a scraper, right? We want it to just be able to essentially work. And to do that uh, requires not only that our Python code works, but also that all the tools that this code, that our code base relies on, right, also is like set up properly. And we need to make sure that, there's no conflicts, right? If we have multiple kind of different tasks running, that one task, the technologies behind it doesn't interfere with the other one. And now that we've been coding a little while, we probably run into issues like that we have the wrong version, or not right. I have not the right version of Postgres installed or whatever. So in order to make sure that something just works, not only like on our computer, but when we deploy it to production, when we have multiple engineers working on the same project on all of their computers as well, we can start essentially the way they used to do this, right, was by starting with a virtual machine and just starting from scratch, installing one piece of technology, then the other, until we have a working application. Okay, and we said that the issue with this virtual machine is that it takes up too much space, essentially, and it also takes a bit of time to boot up. And focusing on the space, to make sure each task works, so it would be like we would need a separate virtual machine, and it would also give us this benefit of making sure that one process, one task, like say the ports that we're allocating for it, don't conflict with another task, right? So that it does give us that benefit of this degree of isolation, this degree of kind of step by step until we have the running application, but it takes a good amount of space. So with Docker, they use this union file system, and the main component of the union file system, and one is that we can have underlying software, right, that is shared between these seemingly separate images. Okay, so for example, we can have the same. Say we have two different images, both that require Postgres. Right, we have this Ghost application that requires Postgres, and then say we have our Flask application, both requiring the same version of Postgres. We can use one underlying version, and it's shared. It looks like it's in both of the folders, right? Both in the folder for Ghost and our custom Flask application. So we're saving space. Then if we ever alter any of that technology, if we ever alter, say, the Postgres image or the Python image, we're not actually altering the underlying image. Instead, what we're doing is we're copying that file that's being changed and then writing to the copy and basically just layering it on top. So for our custom image, this file will be layered on top, but this shared technology underneath will not be altered. So this means that we can have our other images still rely on it. Okay, and this is just a feature of the union file system. It's something built into Linux that Docker takes advantage of. And you can see it. This is why, you can kind of see that things are built on layers in Docker, and that when a piece of technology already exists, you're not reinstalling it. You're just sharing that underlying piece of software. So this is one feature, and then the second feature is just namespaces. This is pretty simple. It's just when we run our processes, we're really running them in a folder. And this is, for instance, we saw this when we booted up Ghost. Remember, it said it was running on port like 2368, but not on our machine. It was running inside of the container. So, right, what you can kind of see happening, what you have to do is map the port that's running in the container over to the host machine. So just to show this, right, if I do Docker image ls, right, and then I run Ghost, Docker run Ghost : for the tag 4.8.0, and I boot this thing up. This is nice. It says that it's running on 2368, but we cannot access it until I shut this down. and then do docker run -p, right, to map the ports. And I'll map, it always goes to the host computer first, right, the port of the host computer that you want to expose. So it's like on my computer, my MacBook, let's say it would map port 9999 to 2368, right? This has to be 2368 because this is, we want to connect to the port in the container that has my application running, okay? So it's like I'm getting a portal into this, like where the process is running, the port where the process is running. So now and you have to shut it down, by the way. Like you can't like forget. It's not a big deal if you forget. Just shut it down and try it again. All right, and now we'll go to 2368, but it's not 2368 anymore, right? It's 9999 on my host computer that maps to 2368. So here we can see it. All right. So in terms of questions about, I guess, I think this is important, just understanding the underlying way that Docker works. And then the other thing to talk about is, right, just think of these layers. You can see, that's what this is illustrating is, all right, in order to get a process working, in order to get, like the website working, we need each of these different technologies until we get to, our code base finally, and then we have the running container. And the container is just one more layer on top of the image that we can then write to. We can, so we add a, we add a new author or a new blog post, right? It's being saved. But right when we shut down our container, this disappears and we start up from scratch again with our image. We will talk about how to get around that, and we will do that. But this is by default how a container works. Okay. Okay, so next what I'll go into is just reviewing some of the command line functions, right? Some of the stuff from the terminal. But anything before we get into that? All right, so there's really just two resources to think about right now. The images, and you can type in, sorry, I should type in Docker image. And if you just type in Docker followed by the name of the resource, you can see a list of the commands. The only ones we're really working with, I think, is this Docker run, Docker pull, right? We said Docker pull is, like if you do Docker ghost, Docker pull ghost will download this image the same way that do git clone. It's essentially that equivalent. And then to run it, you just do Docker run followed by the name of the image. For me, I like looking at the images first. So I'll do Docker image ls. You can see this is the image along with the tag. You could also run it probably by the image ID. But then you do Docker run and say ghost 4.8.0. And for us, we want to put in that flag, right, of the map the port, let's say 9999 to 2368. So this will boot up the image, and we said a running instance of the image is called a container, right? Just the same analogy to we download Google Chrome, it's sitting on our desktop. Then when we boot it up, when we actually double click on it, that's like essentially the container, the running process. We can see that. We can see our containers by just typing Docker container, right? And now we're talking about the container resource. And we can see a list of running containers. What are all the instances of Ghost running if we do Docker container ls? So we can see here, oops. So this is the image that's being run in this container of ID, whatever, right? And then this we'll talk about a little bit later, maybe in a couple minutes, this command thing. And then notice, look, here's our port mapping, that we're mapping my host port of 9999 to 2368. And it just by default gave this container, the running process, it gives that a name of whoever this person is. Great McClintock. So if I want to refer to this thing, right, I can do that by doing like docker stop, I think, and then stop this process. And here it spits it out. And now if I go over here, you can see the ghost is shutting down, ghost is shut down, blah, blah. Okay. So for seeing the running processes, you can do docker container ls, or you can do docker ps. Any questions about that? Okay, cool. All right, let's go a little bit further then. Let me show you. So if we want to like peer, Ghost is like a website, right? And it's running with something a little different than how we built our API, because it's running on Node, I believe, not on Flask, right? So it's running on a different underlying technology. But still, we can like look in we can start to explore it a little bit. The way to do that is we can issue a command to our container, or we can, maybe we'll start there. We'll issue a command to our container. Okay. So the way to do that is we can boot up our container. And now let's take a look at it. Docker ps. So this is our container. And I think I can do this. Docker exec against this container, the ls command. You see that? So I'm saying execute against this container. I can refer to it either by the container ID or by its name. And I'm going to execute the ls command against the container. And now you can start to peer into it. Here's another thing we can kind of do. This is kind of interesting. We can try to, instead of like just list the files, maybe we can like execute bash against the container and then interact with it. Like do ls, change the directory, things like that. So for us to like enter into this container, this actually is not going to work the way we want, but let's just see. You see that? So it didn't give me an error. It actually looks like it's working fine. What's happening is it's executing the task. It is executing bash, and then it's like I completed it. I ran bash against the container. I'm done. So what we need to do actually is we need to do docker exec -it, which stands for like interactive. So run this command and stay connected. And now I am inside the container. Okay, so docker exec is to run a command against a container, and then you specify as the last argument the name of the command you want to run. So the first time I just ran ls, it listed the contents, and then it was done. Right, that process was done. In the second time I just did docker exec, did bash, it did run the bash program, but then it was done. So this time I said run this against the container, but stay connected. So that was this -it. And now you can kind of like look around. Like here's ls. We can cat any of this stuff, I think. Oops, I'm just typing it wrong. Right, and see what's going on. You can use Vim if you know. I guess we'd have to install Vim. Vim just isn't installed in this image, but we could install it if we want to. We can delete stuff, remember that if we change any of this stuff, it's being changed in the container. So right when we shut it down, this image stays the same, right? It's not gonna actually do anything, which is a good thing for us. But yeah, you can explore a container by running that command, by doing that. And then you can always exit out of it and you're fine. The container's still running. We're good. Okay, so the way we did that was doing docker exec -it We can do the container ID or the container name, and then the bash command. That feel okay?
Yeah. Can you open like a VS Code, Jeff, to look at the contents?
You could probably there is like a plugin, I believe.
Okay.
Yeah, that you could use. Right. Last times personally I would just use Vim, but you guys don't know Vim, so you probably would want to just install the VS Code plugin.
Okay.
But there's also other ways. Like we'll get into other ways to interact with the code base. That might even be easier. That'd probably be easier. Another thing that I wanted to show you all is this kind of idea. If you let's go to Docker Hub Ghost. See if I click on the tag. Yeah, you can start to see it here. Okay, isn't the best way. I want to get a link. Oh, there it is. View in GitHub. This is slim. Okay, here's the Docker file. It's so small. Yeah, this shows a better idea. So this is like the Docker file. You can see what it's doing. This is the last step. It's actually showing us kind of it in reverse. What it's doing, oh no, never mind. Sorry about that. It's showing us each of the steps kind of involved in building up this Docker image. So you can see it's setting the node environmental version. Maybe it's installing some sort of package manager. It's setting this other environmental variable, setting this other environment. Each one of these things, by the way, is like a separate layer probably. And then finally at the very end, this is important. It runs this command node current index.js. This is effectively the same as our Flask run command, right? This is the last step. So after we, pip install the requirements, after we set the environmental variables, after we, clone down the repository, then what do we do at the end? Where we do Flask run. This is the same thing except for node, right? We're doing node current index.js. So why is this important? Because this command, you can actually override this command. So normally we want the default command to occur, meaning we want this whole thing to be built, which it is when you download it, and then when you boot up a container, this is what it runs. It runs this last step. But you can say, take the image and override this command. Don't boot up Flask. Instead, list the files. So notice it's not going to, when I do this Docker run, see that it did take a second, and it listed these files, and then it was kind of done. So in other words, what happened was it booted up a container and then listed the files and then died. So if you even tried to do Docker container ls, you won't really see it. It takes too long. It's too short a time. I'd have to switch over, but it did actually boot up a container. And then once it completed the task, it finished. So the default, one point to raise is that the default of behavior of a container is that when the task that you are only booting up a container to run a task, to run a specific command. And once that task is completed, the container's purpose for living is over and it dies. Okay? So that happens with this too. The only difference is when I do this Flask run, what does it mean to boot up a website? It means you're listening for requests. So this task just does not complete until you press Control-C, shut down the web server, and then the task is complete and the container self-destructs and dies. Okay? So in this case, because of this kind of task of stay listening, we can view, it's around long enough for us to see this running container. Once we say, hey, no longer shut down Ghost, right? My site is offline. Then the container itself, this is just shutting down, I believe, the website. But once we're shutting down this task of running node, then the container itself dies. So this is always the same behavior, right? That when I kind of do docker run ghost, and now I override this node current index.js to then say run this task. It runs it, it boots up a container, and then it's done. That container is done. So we run into that same issue of docker run ghost bash, right? I can override the default command to instead do bash. But once that bash command is complete, it's done. The container is done. So instead I need to do the -it. Okay? So here I can avoid, like I'm not running my website right now, right? Because I've overrun this step, this default. So instead I'm just digging around. All right, so I just want to recap for a second. So we saw two ways to kind of issue commands, right? These custom commands on a container. One is we can override the default command that boots up a container by simply providing another argument. So this is the default, docker run ghost. If I want to override that default command, you can do docker run ghost and then type in whatever you want, like run the ls command. If we want to do the bash command, it's -it to keep this persisted, and then put the bash command. So this is overriding the default command, and this is one way for us to, like interact with our container to issue a command against a container, a custom command. Right, just put a separate argument. We will override our default command. The second way that we can do this, that we can issue a command against a container, is to be running ghost, right? Just boot up our container. And now, if I want to, I can see these containers by doing docker ps or docker container ls, and then we can run a command against this existing container, right? So that would be docker exec. That's this exec thing. Exec only works on a container. So I have to provide the container's name or the ID, and then specify what command I want to run against it. So the ls command, that's running it against this container. The other thing I could do is say like the bash command. But again, if I just do bash, it will run this command and be done. So I need to do docker exec -it bash, and then we can dig around. Okay. This thing is still good because we haven't said stop listening yet. Right, this task is not complete of listening for user requests, but once we stop it, then the container dies. Oops, docker ps. Okay. All right, questions about that? Because the